cosine curve has an amplitude of 3 units and a period of 3 pi radians. The equation of the axis is y equals 2 and a horizontal shift of pi by 4 radians to the left has been applied. Write the equation of this function. Alright, before we even do that, let's draw the curve like the normal cosine curve, and then we'll draw this new situation here and we'll compare the two, and then we'll actually write the equation so that we know exactly what we're doing here. Alright, since this is the cosine curve, we're actually saying if I had a circle with radius of 1, this is a radius of 1, and I put a dot at the end right here, and I said, okay, how far to the right is this dot of the y-axis? That's what cosine is asking us. So, and it always starts on the right. So if it starts on the right, we are exactly 1 unit to the right. So the starting point, you're already starting at the right. And so on my graph, I'm saying at my starting point, I'm already 1. So I'm at 1 to the right. And so I put over here 1 to the right. Okay, so now as I move this dot down or around the circle, as you can see, I'm getting closer and closer to this axis. So it's going to get smaller and smaller and smaller. The distance to the right is going to be smaller and smaller and smaller. Okay, and it's going to be, we're going to say right this first dot here, or this first little line here, we're going to say that's pi by 2, which is a quarter turn. And so I'm going to get smaller and smaller and smaller until I get here. Now it's not linear. It doesn't go in a straight line to get there, or straight line this way. It kind of slowly moves towards it and then really quickly moves towards it here. So it's more like, kind of goes slowly and then more quickly there. All right, as you're moving through, once you get to pi by 2, now you're actually going into the negatives. You're actually to the left of that axis all the way to -1. So as you're moving forward this way, you're actually going down to -1. And so we could draw that to -1. And this is pi, which is half a turn. And then we're going back up to 0 and that represents this next third, and you get to 0. And that is at 3 pi by 2. Okay, each one of these dashes is a pi by 2. So it's pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2. Okay, and the last one right here, 4 pi by 2, or better known as just 2 pi, brings us back to the top. So this is the cosine curve. Of course, the sine curve would be a bit different. The sine curve represents how far up and down you are from this dotted line. So we would have started right at 0. We would have moved up to 1, down to 0, and down to -1. Right, those are like our 4 main points. You could do in-betweens. We know that this is going to be 1 over root 2, -1 over root 2, -1 over root 2, and 1 over root 2 for cos. And we also know the 30-degree angle and the 60-degree angle. But that's not for this question here. So we're going to go like that, and then back down to -1. So this is 2 pi. It's going to be 5 pi by 2. And 3 pi over here. I should even go back a little bit and say this is -pi by 2. In other words, if I would have gone backwards from the start, it would still get closer and closer to 0 and going -pi by 2. All right, now let's talk about our new curve up here. So it says it has an amplitude of 3. So instead of just going up 1 and down 1, it's going to go up 3 and down 3. So it's going to be from the top to the bottom, it's going to be 6. Amplitude means from the middle to the top, or from the middle to the bottom if you prefer. Right? So let's see. The equation of the axis is y equals 2. So we're not starting at the middle here. The middle is at 2. So the middle is at 2. We know that it's going to be going, this middle is right here. It's the equation of the axis. You know the highest this guy's going to get is 1, 2, 3 up, and the lowest is going to be 1, 2, 3 downward. So we got 3 up and 3 down with 2 as the middle. All right, that's a lot of information. So we're going to between -1 and 5. What else do we know? We know it's a shift of pi by 4 radians. and that's to the left. So if this here is negative pi by 2, we're going to be starting at negative pi by 4, half of that. So we're going to put our starting point right here at the top. That's where it's starting. Okay. And then it says a period of 3 pi. All right, so let's go. This is pi by 2, pi, 3 pi by 2, and we filled it in all the way to 4 pi. All right, so since this is 3 pi right here, but since we started pi by 4 to the left, then one full cycle is going to end us a little bit to the left of 3 pi as well. So if we started at 0 and we had a period of 3 pi, it would end at 3 pi. But since we started a bit to the left, well, we better start a bit to the left of 3 pi, or end a bit to the left of 3 pi as well. So it's pi by 4 less. Let's say 3 pi is the same as 12 pi by 4. And so pi by 4 to the left is just going to be 11 pi by 4. It's going to be 11 pi by 4. And comma, it's going to have a height of 5. That's going to be back at the top. All right, so halfway in between those two now, halfway in between 0 and pi by 3 is 3 pi by 2 right here. And of course the halfway point won't be at 3 pi by 2, it'll be pi by 4 to the left of that. So it's going to be right about here. And there's our dot right at the bottom. The lowest is going to be 1. So we have, so 3 pi by 2 is 6 pi by 4. So this is going to be 5 pi by 4, comma, negative 1. And now we have to go halfway in between that and the beginning to find our spot. That is going to be right at 2. All right, I'm going to have to start counting some halves. So from the lowest point to the highest point, right, we're going to have I'm going to count each pi by 4 here. So we're going to have 1, 2, 3, 4, 5, 6 pi by 4s. So halfway is going to be 3. 1, 2, 3. So pi by 2 right here is going to be our halfway point there. So that's where it's going to end up at 0. And I'm going to do the same thing on the other side. So we got 1, 2, 3, 4, 5, 6 all the way. So 2, 3. So 2 pi is right when we're going to be back at 0. All right, now I can start drawing this out. It goes down, and then there we go. So you can see that each time we do a quarter turn, it actually goes 3 dashes. Each dash is pi by 4. So it actually does 3 dashes. So we'll go, let's see, right here we're at 1, 2, 3 more dashes will get us to 7 pi by 2. 1, 2, 3 dashes will get us beyond there. There we go. All right, we know our original here is just straight up y equals cosine of x. Now, this guy here is also a y equals cosine of x, sort of, with some modifications, right? So first things first. We know that it doesn't just go up 1 and down 1 anymore. Now it goes up 3 and down 3. So we're going to put a 3 here. Now I'm going to do 2 different versions, and you'll see why in a second. I know that the middle here of my normal one is at 0. It's right at 0. That's the middle. So that's halfway between the top and the bottom. For this one, halfway between the top and the bottom is 2. And so 2 is how much it rose after stretching by 3. So first it stretched by 3, so instead of going up to 1, it goes up to 3, and instead of going down to -1, it went down to -3, and then it moved up by 2. So this -3 went boom, boom to -1, and the positive 3 went boom, boom to 5, and the middle went boom, boom to 2. All right, so the middle is 2, and for both of these equations, I'm going to put a +2 at the end. I'm going to leave a lot of space. Maybe I'll pull that in when I'm done. So the next thing is about the period, right? So the period is 3 pi instead of 2 pi. So the period for this one, instead of in front of that x, is The period is 2 pi, so we actually put 2 pi divided by 2 pi. The period is on the bottom. Well, 2 pi divided by 2 pi just equals 1, so we don't bother putting it. But for this guy, I'm going to put 2 pi divided by 3 pi. Or I could just put 2 over 3 if I want. So I can erase these pi's. They cancel each other out. All right, so you just do 2 pi over the period. Now the reason I'm doing this in two different ways is because some people like to put their brackets here with the x with the 2/3 inside the brackets, and other people like to put their brackets here with the 2/3 outside of the brackets. And that's going to give you two different ways of writing this last number. All right, probably the easiest way is this one down here. So you put plus pi by 4. And that's because it's an actual, we actually moved to the left pi by 4. We actually went to the left by pi by 4 before we started at the top here. Right, so it doesn't start right on the y-axis. It starts, you go to the left a little bit, pi by 4. The other way of looking at it, which might seem strange to some people, but I have a lot of students that kind of, their brain goes this way. We kind of moved, like if you notice that right here, this is one full cycle goes to right here, okay? We kind of moved this guy to the left so that 1/3 of the way to here, it ends up on the x-axis, right? So if you notice, this is negative pi by 4. If you do negative pi by 4 and negative pi by 4 again, gets here, and then negative pi by 4 again, it gets here. So it's 1/3 of the way to this spot here. And then you go, it's 1/6 of the way to 1, 2, 3, to a half cycle, right? So it's almost like saying, if you consider this like a half cycle, like pi, which in this case it isn't, it really isn't. It's a 3 pi by 2 because it's been stretched. But if you look at it the old way and say, well, half a cycle is pi, and we've moved this by 1/6 of that, right? 1, 2, 3, 4, 5, 6. That's kind of like looking at it as, instead of pi, it's 1/6, it's pi by 6, like a 30-degree angle, pi by 6. All right, even though we stretched it first, so it's actually a pi by 4 moved to the left. Some people like to think of it as a 1/6 of this, or even a 1/12 of the full cycle. And so those people would have to write that outside of, like, keep that 2/3 out inside the bracket, right? And this would be plus pi by 6, meaning 1/12 of the full cycle. Now I'm fully aware that half of you are going to look at this and be like, this one makes sense. This one blows me out of the water. Like, I have no idea what he's talking about. And others are going to look at this and be like, yeah, this one actually makes more sense to me. This one kind of, I have no idea what he's talking about. Others will kind of understand both. And other people will only understand one, but then later only understand the other. Okay, so we'll work with both of these all the way through. I'll try to go faster and faster each time, but just remember that if you're doing the actual shift with your new numbers, so it's a shift of pi by 4, considering your 3 pi as your full cycle, then you're going to keep this in brackets. And you're going to put the brackets on the outside if you're going to be considering like a quarter turn as pi by 2, and half a turn as pi, and a full turn as 2 pi. Right? So just as an example, if your new period was like 19 and you knew that you had to do a half turn cycle, well, then the people here would just write 19 over 2, or 9.5, and the people here would just write pi, because that's a half a cycle. Now I really think you should take the time to plug in a number, for example 5 pi by 2, and see exactly where it ends up here. Plug in, I don't know, right here it says, what's this? This is 10 pi by 4, so this will be 11 pi by 4, and make sure you get an answer of 5 for both of these equations, right? And you can pick your favorite, but make sure that you can put it in your calculator and get the proper numbers, right? So if you plug in a negative pi by 4, you should get 5. If you plug in a 5 pi by 4, you should get -1. And then as another little challenge, you could pause the video and do this. Try to find when the y value is equal to 3. Try to find where it's equal to 3.5. See if you can take that apart and do it. All right, just in case someone was having trouble with my challenge there. So this is 3.6. I just let y equal 3.6. So basically I want to know, when is this guy here, here, here? Like, when is it at that height? And I should get a bunch of answers. 3.6 should give me an answer in this region, another one in this region, and another one in this region. Now there's a huge trick here, so you really have to pay attention, because there's one thing that could definitely go wrong. So I'm going to subtract 2 from both sides here. I'm going to get 1.6 is equal to 3 cos. Now, eventually I'm not going to do all of these steps and write them all out, because I'll get good at combining them. But for now, let's just do them all. So I subtracted 2 from both sides. Next thing is I want to divide by 3 on both sides. All right, 1.6 divided by 3 doesn't work out too nicely. I can actually just do 16 over 30. Multiply top and bottom by 10 to make it a little nicer. Or maybe even 8 divided by 15, let's say. You can double check. That's the same as 1.6 over 3. These 3's cancel out, and we have cos of 2/3. Now this is a big trick right here. You can't start dividing by 2/3 or dividing by x, but you can't do any of that, because this is not times. This is not cos times these things. This is the cos of these things. The only way to get rid of this cos is to take the cos inverse. So we're now going to do cos inverse of 8 over 15. But the problem is your calculator is only going to give you one of many answers at this step. This is the step where it screws up. And if you start manipulating and multiplying by 3 and dividing by 2 and doing all that before you figure out all of your possible answers here, then you're going to run into trouble. As soon as you take the cos inverse, which I'm going to do right now, you have to realize that there's not only one answer, there are many. So here I got 1.00826 approximately. So if you're still having trouble with kind of picturing how big of an angle that is, I converted it over here to, it's about 57.8 degrees. Okay, so it's somewhere in this region. Well, if we know that somewhere in this region is the thing that gives me 8 over 15, a height of 8 over 15, which is about 0.533. So it's a little bit higher than half. So maybe it's right about here. Well, we know there's another spot here that's going to give me that same answer. So what is that spot, right? So we've got our 1.00826 is this angle here. So this angle down here that will give me the same distance to the right is going to be negative 1.00826. Right? So we have 1.00826 and negative 1.00826. So we'll put that down here, negative 1.00826. Okay, quick recap here. I wanted 3.6 to equal this equation that we built. So we divided both sides by 3, and we subtracted 2, and then we divided both sides by 3. You have to do the subtraction before you do the division, obviously. Now we have 8/15 is equal to cos of something. When you take your cos, the next step is to take cos inverse. But as soon as you take cos inverse, you get an angle of about 57 degrees here, a little 58 degrees-ish. Right? 1.00826 radians. If you remember, 3.14 radians is half a circle. 1 is right about here. All right, so you have to then realize that since we're doing the cos inverse, it's saying what angle is giving me a distance of about 0.533, 8/15, 0.5333. The distance to the right is 0.5333, right? We have to know that there's another angle that gives us the same distance to the right that is perfectly symmetrical. So if this angle here is 1.008 0.00826, well then the negative 1.00826 should give me the exact same answer. All right, now that we have these two answers, we could actually get more answers, because I know that if I were to take, if I were to go 1.866, I would get that distance to the right. But if I were to keep going, it would go down to the negatives, back to the positives. Oh, there's another spot here. And I keep going, and there's another spot here. And then I keep going around, and it happens again, and it happens again. And so each time you add one full round of 2 pi, you could get more answers, right? So if I took 1.00826 and I said plus 2 pi, that would be another answer. If I took this one and added 2 pi, that would be another answer. So there are several answers that are going to work. Once you have all these answers, now you can finish your equation. Right? So now I'm going to take each one of them and I'm going to multiply by 3, I'm going to divide by 2, and then I'm going to subtract pi by 4 to find these answers. So I'm going to go ahead and do that. Now just a bit of a recap here. What we did was we took 3.6, right? We subtracted 2, we divided by 3, and we got 8/15 is equal to the cos of all of this garbage, right? Then we did the cos inverse, and as soon as we did the cos inverse, we ended up with an answer of 1.00826, but we recognize the fact that that is this angle right here, 1.0082601, right? But also we need to remember that there's another point that the calculator didn't necessarily tell us that's on the other side, like that's below this point right here, that also gives us a cosine of 8/15, right? So you have to be able to on your own say, okay, well, if this one works, well, I know the symmetry says there's always two of them on the circle that work. And so negative 1.0082601 also works. And so that's right here and right here. I end up with two equations. But then you have to realize that's only on the first cycle, right? So if I add 2 pi to this guy, so right in here, you got 7.29, whatever. That's a third answer. And if I add 2 pi to this guy, that's a fourth answer. And I could add another 2 pi and get a fifth answer to both of these guys, a fifth and a sixth answer. I could actually subtract 2 pi from both of these guys. And I could keep doing that infinitely many times. So there are many, many solutions. And that makes sense because this graph shows us all the spots that are a height of 3.6, there'll be one here, there'll be one here, there'll be one here, and so on and so forth, okay? And you can even go backwards and forward. So there are billions and billions of answers. We still don't know what that spot is. We know that that spot is x, and I know that if you take x and you add pi by 4 and multiply by 2/3, we're going to get those spots. But we still have to undo this. So we're going to have to multiply by 3 still, divide by 2, and then we'll get x plus pi by 4, and then we have to still subtract pi by 4, and that will give us our x value. So first let's multiply everything by 3 and divide everything by 2. Alright, there we go. So I multiplied by 3 and divided by 2, and now this is now just equal to x plus pi by 4. Same with this. I multiply by 3 divided by 2. I got this, and it's now x plus pi by 4. Now we're going to take these four answers and we're just going to subtract pi by 4, and then we'll have our x value. So here we have x value of 0.7269920 approximately, 10.1517699 approximately, negative 2.2977 blah blah blah, and 7.12. So let's look on our graph. This first one here is approximately 0.7269920, this x value right here. And if you go back this way, another spot would be at negative 2.29 would be another spot where that would hit that height. And then another spot would be at 7.12, which would be right about here. And then another one at 10.15 in this area here. So these are the spots that hit 3.6 approximately. All right, I'm completely aware that I went way beyond question number 1 though there, but I think this will be very useful for us in the future anyway. We did get our equation of y equals 3 cos of 2/3 of x plus pi by 4 plus 2, this guy. But I also wanted to show you, what if I gave you a y value? How would you undo this to get the proper answer? And the key is, when you do your cos inverse, you got some work to do. The calculator gives you one answer, but you need to be capable of finding 1, 2, 3, 4, 5, 6, like millions of different answers, all the different possible answers. All right, question number 2. Determine the value of the function in question 1. So I wrote the function here. If x is pi by 2, 3 pi by 4, and 11 pi by 6. All right, let's do that. So one smart thing to do is just let y equal f of x. And that way it's just much easier to write the equation with x values in here. I don't have to write x, if x equals pi by 2, y equals, and write it in. I could just straight up write f of pi by 2, f of 3 pi by 4, and f of 11 pi by 6, and just change the x to those values. Now we just solve. We could just write in the calculator 3 times the cos of open bracket 2 divided by 3 open bracket pi divided by 2 plus pi divided by 4 close bracket plus 2. And the answer is 2. Same thing for 3 pi by 4. And we get 0.5. And 11 pi by 6 gives us 0.9739396 approximately. So if you look at our graph from question 1, we could say f of pi by 2. Now this graph isn't perfect or anything, but f of pi by 2, yep, it is actually at 2. F of 3 pi by 4, 0.5, 3 pi by 4. That's right here. It looks like this graph goes down a little bit too low. So it's right around here at 0.5. And 11 pi by 6, that's somewhere in this region. Here's 1. Yeah, I could believe that's just about 1 there, 0.973. So this seems to be the correct answers here. All right, question 3. Sketch a graph of the function in question 1. Oh, that's convenient because we already did that. Use your graph to estimate the x values in the domain between 0 and 2. So 0 and 2. This is 0. 2 would be, so this is about 3.14. So 2 is somewhere in this region, where y is equal to 2.5 to 1 decimal place. So 2.5 would be right here. Gosh, I don't know. Maybe that is equal to, let's see, I know pi by 2 is equal to about 1.57. It's because 3.14 divided by 2 is about 1.57. And that's when this is equal to 2. So it's a little bit above that. So it's going to be just before that value. So I'm going to say like maybe 1.3-ish, I guess, would be a pretty fair guess. So let's just say when x is equal to 1.3. Number 5. Mike is waving a sparkler in a circular motion at a constant speed. The tip of the sparkler is moving in a plane that's perpendicular to the ground. The height of the tip of the sparkler above the ground as a function of time can be modeled by a sinusoidal function. Yeah, it can. At t equals 0, the sparkler is at its highest point above the ground. What does the amplitude of the sinusoidal function represent in this situation? All right, if I were to draw a graph that represented the height over time, it would start at the top, so it would start right about at this height. And as he starts as it goes around in circles, it would go lower and then back up. So go all the way, the least would be down here. Right, so we go down and then back up like this. It'd be a lot like it is a cosine curve that starts up here. The amplitude, so what is the period? Oh yeah, amplitude. So the amplitude is from the middle point up to the top, or from the middle point down to the bottom. So in this case, what does the amplitude represent in this situation? So the amplitude is going to be this distance here. So half the distance that it is from the top of where he, like the highest point that he turns this sparkler to the lowest point that he turns this sparkler. That would be the amplitude. So this distance here or you can say it's this distance here, same thing. What does the period of the sinusoidal function represent in this situation? The period is how long it takes to do one full cycle, right? So go from the top down to the bottom, back to the top. So in this situation, it represents the amount of time that it takes for this spark to go all the way around once. What does the equation of the axis of the sinusoidal function represent? The equation of the axis, so y equals this height right here, represents the center of the actual circle. So the height that's halfway in between the maximum height and the lowest height. If no horizontal translations are required to model this situation, should a sine or cosine function be used? Well, it starts at the top and goes down to the bottom. That's exactly what a cosine curve does. It starts at its highest value and then goes down to the lowest value and back up. A sine curve starts at the middle, goes up before it goes down to the middle, and then down and then back up. So definitely we would want to use a cosine curve. Now specifically the amplitude would go here, amplitude. The height off the ground of the middle, so we would call that the axis of the curve, the height to the axis of the curve. So let's call that, I don't know, d, distance from the ground of the middle. So that would be plus d over here. Whatever the period is from here to here, so however much time it takes to do one full cycle, let's just call that p for now. That would be 2 pi over p would go there. And then this, you just have to put x, because there's no, you don't have to do plus or minus anything because we're starting at the top. So that's actually a smart move to start with, use a cos curve so that we don't have to shift it left or right. And so this would be our equation. All right, number 10. This is a similar question that I've given you guys already. Number of hours of daylight in Vancouver can be modeled by a sinusoidal function of time in days. The longest day of the year is June 21st with 15.7 hours, and the shortest is December 21st with 8.3 hours of daylight. Find an equation for n of t, all right, so it's going to be n of t equals, which is the number of daylight hours on the nth day of the year. That actually doesn't make sense. T should be the day of the year. You're plugging in a t to find the number of daylight hours, so it should be the tth day of the year. All right, the equation is, let's use a sine curve. All right, we're going to have to find the amplitude. So the highest is 15.7 right here, and the lowest is 8.3. So that has a difference of 7.4 total. 7.4 total, which means the amplitude is half of that. So 3.7 to the halfway point. And just to say where that halfway point is, add 3.7, so we got 12.0 is the halfway point. So 3.7 is your amplitude, which is the distance from the top to the middle, or the distance from the bottom to the middle, however you like. 2 pi, you're going to put over 365. Now you might want to put 365.25. I don't know what you want to do to include leap years, but let's just put 365 for now. All right, normally the sine curve starts in the middle, heads up, and then down, and then down, and then up. All right, since I know the hottest day of the year is June 21st, which is the 172nd day. It's June 21st. Why don't we start, instead of a sine curve, why don't we erase this sine thing, and we'll use cosine, because it'll be easier to find the starting time. All right, so we're going to say x plus or minus something. So normally we start at the top, and we do a full cycle like this. But now we're starting somewhere in January, which is like one of the coldest days, and then we're going to eventually get up to June and then go down. And so we've moved it to the right by 172 days. On the 172nd day, that's when we're finally at the top. So we're going to say minus 172. And then just our middle is at 12, so we're going to say plus 12. Now, just to double check, if I plug in 172, so June 21st, this will equal 172 minus 172. Well, that's 0. So 2 pi divided by 365 times 0 is just 0. The cos of 0, we actually know, is equal to 1. 3.7 times 1 is 3.7. Plus 12 is going to be 15.7. And that's the highest point. And we do know that June 21st, 172 should be the highest point. So that makes me feel pretty good. Part B, use your equation to predict the number of hours of daylight in Vancouver on January 30th. Well, January 30th will be the 30th day. So I just have to plug in a 30. So n of 30 equals 3.7 cos of 2 pi by 365 times 30 minus 172 plus 12. And put that in my calculator. I get approximately 9.16. Therefore, there are about 9.16 hours of daylight on January 30th. All right, that's not fair. This 0.16 hours, nobody does that. So let's see what 0.16 hours is. 0.16 times 60. So it's another 9, almost 10 minutes. So we can say 9 hours and 10 minutes of daylight. Number 11. The city of Thunder Bay, Ontario has average monthly temperatures that vary between negative 14.8 and 17.6. Following table gives the average monthly temperatures averaged over many years. Determine the equation of the sine function that describes the data and use your equation to determine the times that the temperature is below 0 degrees Celsius. All right, this isn't going to be perfect, mind you, but let's do our best here. So let's say it won't be perfect because, I mean, temperatures don't exactly follow a sinusoidal curve. But let's try it out. Looks like the lowest temperature, so if this, oh yeah, negative 14.8, they told us that. Negative 14.8 is our lowest. Our highest temperature is at 17.6. All right, so halfway in between them, well, let's see what the distance is between them. So 17.6 and 14.8 is what, 32.4? So 32.4 total. So halfway is going to be 16.2. 16.2, which means that we're going to be the middle is going to be at 1.4 degrees. Ooh, that's awful. Okay. Now you can see already that it's not that accurate, right? Because 1.4, April would be, so January, February, March, April. April should be about 1.4. July is the hottest. August, September, October should be about 1.4. And they're a bit hotter than that. But we're just going to use this data because that's what they're encouraging us to use. And we're saying negative 14.8 is about here. Negative 14.8, 17.6, and 1.4 is our axis of the curve. Now I think I'm going to make life easiest for myself and be clever here. I see this is the lowest point, and then it goes up, 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 and it keeps going up, and July is the highest point. A sinusoidal would start in this range here. So like at April, that way it would go up, then down farther, and then up again. So if I'm going to use a sine curve as an equation, I might as well make day 1 mid-April. So I'm going to start mid-April right here. Mid-April. That way I can actually start right at my spot. Now I know that it's 2.5, but 1.4 is really what this sine curve is going to give us. So we're going to be off by a little bit. And then by the time we get to, let's see, April, May, June, July, mid-July, then we're going to be up at 17.6, and then we're going to call this August, September, October, mid-October maybe. And it's going to be back down, and then we'll say this is going to be January, mid-January, and that's when it's going to be down to negative 14.8. And then of course we go back to April. There we go. There's a graph of our curve. All right, this equation should be quite easy now. So we got y equals, the amplitude is 16.2. It's from the middle to the top or from the middle to the bottom, however you like. You go sine and 2 pi divided by, what's the, we could either do 365 or we could just do like 12 for 12 months. Let's do 365 so we can kind of know the daily. Now let's do 12 because really it's only about the monthly divided by 12, so the period of 12. And x, we don't have to do x minus or x plus something because it's actually starting exactly where my sine curve would start. But we do have to go up 1.4 because the center is up 1.4. And there's my equation. So now let's determine when the temperature would be below 0. So let's find when it's equal to 0. So right here and right here, how many months in, and then we'll know that it's between those two. So let's say 0 equals 16.2 sine 2 pi by 12x plus 1.4. I'm going to subtract 1.4 from both sides. Negative 1.4 divide 16.2. That is equal to sine of 2 pi x over 12. Now I have to do the sine inverse before I touch any of this. And I have to remember that there are two answers I'm looking for. This guy and this guy. So let's see. We're going to do the sine inverse of negative 1.4 divided by 16.2. Now my calculator gave me an answer of negative 0.0865 approximate. So negative 0.086527. But I know that's not the one I'm looking for. That's this dot right here. And for the sine curve, I know that there's going to be another one over here. So the first thing I'm going to do, instead of taking the negative one, I'm going to add 2 pi to that to get the positive one here. And then I'm going to find the equivalent over here. Or I could do it in any order right now. So if I got this negative 0.08625, that's this angle, this little angle right here. So that means that's going to be the positive of that will be this angle in here too. So if I just take 0.0, so I'm just going to take the negative of that, and then I'm going to add it to pi, and I'll have this answer right here. And I'll also take this answer and I'll add 2 pi and I'll get that answer here. All right, so I ended up with 2, so we still don't have our answer for x, but I ended up with 2 pi x over 12 is now equal to, so I did the sine inverse of this and I got negative 0.08, but I knew better than that. I know there are many answers when you do sine inverse. And so I actually took that 0.086527 and I added it to pi to find the other one that would be at that same height, which is a little bit below the axis. And then I found another one by taking this negative and adding 2 pi to get that second one. So I got 3.22812 approximately and 6.126. Now I'm going to multiply them both by 12 and divide by pi by 2 pi to see what my x will equal. All right, I multiplied by 12 and divided by 2 pi. 2 pi is like almost half of 12, so really it almost just doubled these things. It didn't quite double them. So it's 3.222 times 12 divided by 2 pi is 6.2, and this guy times 12 divided by 2 pi is 11.8. So x is 6.2 and 11.8. 11.8. So we're going to say 11.8 is almost 12 months later. Not quite. So 12 months later is here. And sure enough, it hits 0 right before we're at the 12 months. At 12 months, we're at 1.4, right? Because we start at 1.4. 12 months, we're at 1.4. And right here is this 0. Let's look at the 6.2. So that's from mid-April, we have 6.2. So 1, 2, 3, 4, 5, 6. So October and a little bit between October and November area. And sure enough, that's just past October is where we have this dot. Right? So if we're saying this is mid-April, so 1, 2, 3, 4, 5, 6 would be mid-October, and 0.2 would be late October. So from late October, and this 11.8, so mid-April, this would be mid-April again the next year, and we're going to be about 0.2 short, so we're going to be early April. So from late October to early April, we should expect to have freezing weather below 0 degrees Celsius.